that you still have a 1 in the numerator, right? You still have a 1 in the numerator. So we're almost there. Limit h goes to 0. I have a 1 on top, and on the bottom I still have that 2 plus h. And now finally, let h go to 0, and you get 1/2. We should get the same answer, yeah? We should get the same answer. So what do you think? Did you all like the first definition or the second, or did it seem about the same? You like the second one, about the same? So, you know, some problems, the first definition is better because the algebra is easier. Sometimes the second definition is better because the algebra is easier. You really wouldn't know unless you tried doing both methods. Then you could compare the two. My advice to you is to don't get married to one definition, okay? Be open to both, right? Because sometimes if you're getting really hung up on the algebra, you say, you know what, let me try the other definition, maybe things are going to be nicer. All right, yeah, so now let's do a different example, all right? Let's do something else using that same definition. But this time, I'm going to change it up. On our Zoom session, I had shown you a problem where, let me bring it up. Let me see if I actually have it right here. Oh, you know what? I haven't synced I didn't sync it. So there was a problem that I did where I asked you to find the slope of the tangent line, and I asked you to do it like 5 or 6 different points, right? And I said, wait a minute, instead of doing that, let's find a generic formula for it, and then we can just reuse that formula over and over. I want to do that right now, all right? So if f of x equals, what do y'all want here? Level of difficulty. Let's go 1 to 5. 1 being like simple, 5 being like as bad as you'll see on a test. What do you all want to see? Like a 3-ish? 3 or 4? Okay, let me do this. Let me do 1 over the square root of 2x plus 1. All right? If f of x is that function, I want us to find f prime of a. Right, so this, you have to go back to last class to understand what I'm asking here. So let me remind you about last class. Last class at the end, I said that this notation, f prime of a, is just the slope of the tangent line, right? That's all it is. This right here is the slope of the tangent line at x equals a. It's a generic, it's a formula that we would get that would give us the slope of the tangent line if somebody supplied us the a value. And last class in Zoom, I said, well, then that's just going to be the limit as x approaches a of f of x minus f of a all over x minus a, right? That's what I said last class. But now we can say, or we have a second definition, limit h goes to 0 of f of a plus h minus f of a all over h. We have choices now of which one we want to use. Okay? So let's do this problem, but let's force ourselves to use this definition just so we can get another practice problem with it, right? So here we go. So to find this will be equal to the limit as h goes to 0. All right. What is a for us in this problem? It's kind of a trick question. It's just a, right? It's not a number. I'm not giving you a is 1, right? So we have to leave a. So I'm going to use this formula right here. I don't want to write it down again. Let's just use this formula. All right. I need to figure out what f is if you plug a plus h into it, right? So what would happen if I take a plus h, right? And I take that and I insert that in for x here in here, right? What would that look like? So here's what it would be. 1 over square root of 2 parenthesis a plus h plus 1. Everyone agree and understand that that's what I get when I plug a plus h into the function? Yeah? No questions? I subtract from that f of a, which means what do you get when you plug a into that function? Well, that just means replace the x with a, right? So it'll become minus, right there, 1 over square root of 2a plus 1. See here I had to put parentheses because I replaced the x with a plus h, and that 2 has to pass through. Here, when I replace the x with a, it's just 2 times a. There's no need for parentheses there, right? All over h. All right, that's what we have to figure out. I have your quizzes from last time, and I have the sign-in sheet. So is it okay if I pass the quizzes around? Any objections? Everyone's okay with that? Okay, here they come. Please grab yours and pass them out. And then today is the 7th. So just initial in, yes?
Are we still getting that credit for doing the Zoom?
Yes, I will do it later, but because I have to go back to the Zoom and actually look, but I will. And I promise people will not let me forget.
Yeah.
Right? All right, you ready? How does this look to you? When you see that, does it make you sick? Does that look complicated to you? Yeah? It is. That's a pretty complicated problem. I mean, there's a lot going on here. So, do I need to check, or do you believe me that if I let h go to 0, this is going to give me 0 over 0? Do y'all believe that? It should, right? It should, because remember, what we're doing is we're sliding a point on top of another point, right? So if you do that, the rise over run should become 0 over 0. So we know that's what should happen. So I don't need to do that step. I just need to see if I can eventually get this h to cancel. That's my goal. Can I get that h to go away? So I see complex fractions, and I also see square roots. So whenever we see complex fractions, we think common denominator, but when we see square roots, we think conjugate, don't we? So whenever you have both of those situations, I always recommend doing common denominator and putting them together first. All right? Don't try conjugate right now. You can, but it's more complicated, trust me. Also, I do have an option. I can leave this in parentheses, or I can distribute the 2 through. What would you all like me to do? Leave it for now or distribute? Distribute? Okay, let me do a new line. All right, so here we go. Nothing new other than distributing the 2 through the parenthesis, 2a plus 2h plus 1. I cannot collect any of those together. They're not like terms, so I'm just going to leave them like that. 1 over square root of 2a plus 1. And then all of that over h. All right. I need to get a common denominator and put these two things together. That's a pretty nasty common denominator that I'm going to need, because I need this right here, the whole thing, I need it right next to this one. So I need it on the top and bottom. And then this one, I need it also on the top and bottom. So it's going to look terrible, but let's do it. All right, we're calculus students, so we should not be intimidated by that algebra. All right, limit h goes to 0. I'm going to leave some space here. I'm really trying to show y'all as much work as possible. I'm leaving it up to you to tell me if you need me to explain something to you. You have to have the guts to stop me and say, hey, I don't understand that step. All right, so here we go. Here comes my common denominator part. So I'm going to multiply this fraction over here by 1, and I'm going to multiply this fraction here by 1. But the one that I'm going to choose is root 2a plus 1. Root 2a plus 1. All right, heads up, everyone. Oh, I was trying to bank it. You mind getting that for me? Thank you. All right, square root of 2a plus 2h plus 1, square root of 2a plus 2h plus 1. All right, that's what I'm about to do. All right, when we multiply these two fractions together, we multiply straight across, right? So it's just that root times 1, and then these two multiplied, right? Do not multiply them, just keep them, we're just going to keep it just like that, all right? And then over here, this 1 times that, and then these two, but let's not multiply them, all right? So I have limit, h goes to 0. All right, I have root 2a plus 1. That's this times this, right? Now I'm going to try and do 2 steps at once here and see how y'all do. I'm going to go ahead and put them together right now. So if I do this times 1, then I will subtract from that 1 times that, right? So I'm going to subtract from that 1 times that, which just becomes this. And then all of that is over the common denominator, which is root 2a plus 1, root 2a plus 2h plus 1. So remember I said our common denominator is this, but let's not multiply them together, right? Then all of that over h. Any questions on that step? Bless you. I would say this is like a level 4, level 5 problem here in terms of the algebra. No questions? We're all okay up to this step? We have combined, we got a common denominator. Now, conjugate. Now bring in the conjugate. So when I say conjugate, I mean look at this numerator. It's ugly. Bring in the conjugate of this thing. And we're going to multiply the top and bottom right here by that conjugate. And to save myself time, I'm just going to do it right now, and I'm doing a different color so you know that I inserted it. So I'm multiplying here, top and bottom, by the conjugate of the top. Root 2a plus 1 plus root 2a plus 2h plus 1. And then I have to do the exact same thing on the bottom. Root 2a plus 1 plus root 2a plus 2h plus 1. Okay, it's coming again. Oh, whoa, whoa. My pre-cal students can attest to that is normal for me to miss, right? Ugly, yes? Ugly? Now, when we multiply these, we have to do like all of this times all of that, right? And then on the bottom, same thing, all of this times these two, right? Oh my goodness, that looks horrible. All right, let's do this multiplication. The top one right here. It looks like a disaster, but it's a conjugate, so good things do happen with conjugates, right? So if I do this times this, they're exactly the same thing, aren't they? So the square root goes away, and all you're left with is what? 2a plus 1, right? So 2a plus 1. All right, the middle multiplications, the middle ones, which I'll show in green, that one and that one, you don't have to do because those cancel each other out, guaranteed, every time, right? Because it's conjugate. But now I have to do that last multiplication, and this is the one that is really gets people. I'm doing this one times that one, right? They're the exact same roots, aren't they? So the root should go away, right? But that's a negative and that's a positive, right? So you're gonna have a minus, aren't you? So you have to write this, minus, and then parentheses, whatever was under the root, 2a plus 2h plus 1. That's the mistake people make, is that they make the root go away, and they do put a negative out here, but they don't put the parentheses, so that negative never distributes, and then it messes everything up. Okay, that's the numerator, right? That's the multiplication of the top. What do you think I'm going to do the bottom? Do you think I'm going to multiply it out? No, I'm not. Because my hope is that this h cancels with something up here, right? I don't really care about what happens here. I really want my h to cancel from something up there. So I'm not going to touch the denominator. And it just looks horrible, doesn't it? Parenthesis, root 2a plus 1 times the square root of 2a plus 2h plus 1. And then I'm multiplying that by the square root of 2a plus 1, and then plus the square root of 2a plus 2h plus 1. Close parentheses. Y'all do see that these two things are not the same thing, right? This one has a plus between them, and this has multiplication between them. All right, all of that over h, right? Boom. All right, and now I hope for the best here, right? I'm really hoping that up here things get good. Let me distribute this through. And to save ourselves a little bit of space and time, let me just write above that what that is. That's minus 2a minus 2h minus 1, right? That's what I get there when I do this distribution. And then right here, that's just 2a plus 1, right? And do y'all see things start going away? What do I get to go away here? 2a goes away. The 1's go away. And all I'm left with on top is a negative 2h, right? Negative 2h. So this becomes the limit. H goes to 0. I have a negative 2h on top. I have this big, nasty, ugly looking thing here. Parenthesis, square root 2a plus 1 plus square root 2a plus 2h plus 1. And then all of this, all of that over h still, right? All over h. And what do you think I'm going to do with that h on the bottom? Flip it and bring it up. So the h on the bottom is really going to look at this h here as an h over 1, and then I'm going to flip it and bring it as a multiplication, so it becomes 1 over h over here. And I'm doing that so that I can clearly see the h's go away. Any questions on that step? Just looking at this bottom h as an h over 1 and just flipping, and we've done this a few times, yeah? See, I told you, you tell me if you agree with this. Do you feel like the concept of the calculus is difficult? Like the idea of sliding a point, do you find that difficult, or is it more like the algebra? See, the algebra is the problem? That's the way, I mean, that's just historically, that's what students have said. It's like, I understand what we're supposed to do. I'm just having trouble doing it, right? The algebra is holding me back. So, all right, we continue, right? Well, I think I'm going to try and do this limit now, all right? I'm going to actually try and let h go to 0 at this point. So equals, no more limit now. What's the numerator? What's up top? Negative 2, okay? Negative 2 is on top. Okay, let's separate that. Actually, I'm going to erase it. I don't want this anymore. Okay, oh, negative 2, sorry. Negative 2. All right, now the bottom. All I'm going to do is everywhere I see an h, and I'm going to let it go to 0. So do y'all see there's no h's here, right? Nothing happens to this. So that's still the square root of 2a plus 1. Got it? Next to it, I have the square root of now. Let h go to 0. If h goes to 0, doesn't it kill this off and make that go away completely? Right? So what are you still left with underneath that root? 2a plus 1 again, right? All right, that's what I have there. And then in the other set of parentheses here, let's see what happens. This does not have an h in it, right? So I still have square root of 2a plus 1 plus, and then again on this one, this h goes away, right? And if that h goes away, we get a square root of 2a plus 1. Now this is our generic formula. This is it. Now I can go to any point on this graph and I can tell you the slope of the tangent line. All you have to give me is the a value, and I will give you the slope by plugging it in here. I'm going to do that in a second, but let me clean this up because this still looks bad. Do y'all see these two roots are exactly the same? And do you see I have multiplication? So the root goes away, right? So let me continue this up here.
On the test, do we have to clean this up?
I think you should. I think you should because later on we're going to do something with this and you're going to have to clean it up to continue moving on in the problem.
On the last one, you didn't clean it up, so I just wanted to make sure.
On the last one, what was the last one? I forgot what it was. What do you mean the last one? I thought the last one was a number. Because we got 1/2. Right? This is the first one I've done where we have a formula at the end. Oh, you're talking about the equation of the line.
Oh, yeah.
Yeah, I didn't solve for y, I just left it. That's okay. But when you have something like this, we want to try and clean it, if it's easy. To me, this is that right there, putting together, I think is a pretty okay thing to ask you to do. Two roots, exactly the same, you're multiplying them, the root goes away, right? So if the root goes away, I just get 2a plus 1, right? And I'm going to put that in parentheses. That's this. Now be careful. These two are not being multiplied, they're being added. But they are the same, aren't they? So if I have an apple plus an apple, I have 2 apples. So I'm going to say in the other parenthesis, 2 of those square root of 2a plus 1s. That. Understand? And now, I guess the only thing really left for me to do, well, there's a couple of things. Oh, do y'all see that this 2 here and this 2 can go away? This is all multiplication on the bottom, isn't it? So because it's multiplied, I can cancel the 2's. So I'm left with a -1 on top, and then I have in parentheses 2a plus 1, and then square root of 2a plus 1. That's a pretty clean answer, isn't it? Like it's better than this. But there's an even better one, okay? You ready? I'm going to show you, there's one more step that you can do. And before I do it, let me remind you of something. Do y'all all agree that the square root of x is the same as x to the half power, right? Yes? That's what that means? Also, do you agree that if I have x and I multiply it times x to the half power, that what you do is you take the powers, since there's multiplication, you add those two powers together, right? So what I want you to see on this answer right here is that what we have is -1 on top, then I have 2a plus 1 to the first power times 2a plus 1 to the half power. Do y'all agree? 2a plus 1 to the first, 2a plus 1 to the half. And now these have the same base, right? We're multiplying them, and so you add those exponents. And what's 1 plus a half? 1.5? 3/2. So when you add 1 plus a half, you can say that's 1.5, okay? That's called a mixed number, right? That's called a mixed number. And in calculus, we don't use mixed numbers. We just don't, because they're tedious for what we need to do with them. So instead what we do is we get a common denominator, 2/2, and we add them, we get 3/2. So when I put those two together, I get -1 over, this is my final answer, 2a plus 1 to the 3 halves. Boom, there's my answer. There's my generic formula. It only took us, what, 20-something minutes? A lot of work there. All right, let's see this thing in action. All right, we invested quite a bit of time into that, right? Let's see if we can like see that it paid off. Our work has paid off for us. So we had this function, right? F of x. It was 1 over the square root of 2x plus 1. That was the function. And I'm actually going to graph it for us right now. One over the square root of 2x plus 1. All right, there's the graph of the function, all right? And let me write down our formula over here. That was the formula we came up with, right? And so now I want us to pick any point on this graph, any x value we want, and to keep things nice, let me start with 4 because I know what's going to happen here. Let's go to 4. If I ask you, what is the slope of the tangent line there? Not the equation, just tell me what the slope is, right? Well, all we have to do is what? Take that 4 and do what with it? Plug it into that formula we just found for A. Okay, so let's plug it in here. If I'm going to say at x equals 4, the slope of the tangent line will be equal to -1 over 2 times 4 plus 1 raised to the 3 halves. Which is equal to -1 over, all right, 2 times 4? 8 plus 1, 9, right? So the bottom is 9 to the 3 halves. All right, let's talk about 9 to the 3 halves. 9 to the 3 halves is the same as taking the square root of 9 and then cubing the answer. So whatever the number is down here, the denominator, is the root you're taking, and whatever the number is up here is the power you're going to put it to. Y'all see that? So you're taking 9, you're taking the square root. What's square root of 9? Square root of 9? 3, and then cubed. 3 times 3 times 3? 27. 27. So this is going to be -1 over 27. Does that answer make sense to you? It does? Slope of the tangent line, right? So we're looking at this point right here. We're trying to find the slope of that line that's tangent. Do you all agree that it's just kind of pitched down, just a little bit of a pitch to it? So remember with lines, if your slope is like that, it's a positive slope, right? This is a negative slope, and this is a slope of 0 if it's flat. So if I just tilt a little bit like that, I should have a small negative number, right? That's a small negative number, isn't it? -1 over 27? Let's try another one, another point. See, this formula is like a magic formula. I can go to any point I want and figure out what the slope is. So what would be an easy 15? You know what? How about 0? How about 0? That point right there. That should be pretty easy for us to plug in, right? I mean, can I erase this? Anyone need this? Okay, so at x equals 0, we get that the slope of the tangent line will be equal to -1 over 2 times 0 plus 1 to the 3 halves, which is -1 over, let's see, 2 times 0 is 0, 0 plus 1 is 1, so I get 1 raised to the 3 halves. What's 1 to any power? 1. So this is just -1 over 1, which is -1. Does that make sense to you? Does the picture match what we're getting there? Does the slope of that tangent line look like it's about -1 to you? Yeah? All right, got it? Yes? Okay, now I have a more profound question, all right? Let's say that I never gave you the graph, okay? I never gave you the graph of this function. You don't know what it looks like, right? But when you calculate the derivative, right, that's what that's called. When you calculated this f prime of a, you got negative 1 over 2a plus 1 to the 3 halves, right? You calculate that. The profound idea here is that I know by looking at that right here, just by looking at this right now, I know that if I graph this function, it's never going to go up. It's always going down. How do I know that? Because the top is negative, right? That's not quite enough though, because what if the bottom's negative? A negative over negative would be positive, right? Ah, well, not squaring, we're square root. And you can't take the square root of a negative, right? So I know that in the bottom here, let me rewrite this bottom. This bottom, another way I could write it is the square root of 2a plus 1 cubed. I know that I'm not allowed to plug negative numbers in here. I mean, I'm not allowed to plug something in that's going to make this negative, because then I can't take the square root. So this is always going to be positive no matter what. And if this is positive and I cube it, it's still positive. And therefore, a negative over a positive will always be negative, which tells me that that graph always goes down. Later on, we will say that this graph is decreasing. It's a decreasing function. And we can tell by just looking at its derivative that it's decreasing. That kind of makes sense? All right, 9, 6. Let me bring up the notes real quick and just see where we are. Everything that I've said here today in terms of this new definition, it's all in your notes. If you need to go back and look at it, I even put here, look, second version, right? Second version right there. You can look at that, and I go through the derivation of it. All right, so here's the big summary, all right, of everything. And that is, if you're given some curve, the equation of the line tangent to the curve at some point is one of these two formulas. This is the point slope formula, right? Y minus a point, the y coordinate, equals this whole thing is the slope of the tangent line, right? At some point A, and then x minus a. It's that one or this one. See, these are just the two definitions, provided these limits exist. All right. Then I talked last class about the derivative, right? We said, okay, from now on, these limits, these two new limits we have a new name for them. They're called f prime of a, which is called the derivative of the function f at a, or f prime of a.